stop being judgy. You like the really girly pinks and I don't. If that's it.
Oh, we'll just let that one lie. All right, so we're
Welcome to 2.5, all about correlation. Correlation, like the relationships between the two variables that we're talking about. Today we're going to talk about how do you determine the correlation of a linear relationship, and then also once you find that correlation, how do you interpret that correlation? So really quick, our essential knowledge for this lesson is the R value. So in Algebra 2, you may have talked about this R value before. Your Algebra 2 teacher probably told you something along these lines. If the R value is 1, then the linear or the line model, the line of best fit, is a really good positive fit. And if the R value is -1, then it's also a really good fit, but it's now a decreasing line for a line of best fit. And if the R value is close to 0, that means the data is scattered all over the place and it doesn't really look like a line, right? So we're here to tell you that the R value is 1 over n-1 times sigma of x minus x bar over the standard deviation of that.
I can't believe you even started. That scared the heck out of me, and I have a master's degree in math. That equation looks terrible. All right, but we'll talk about it. The wonderful thing is you're not going to have to actually compute it by hand. Okay, we don't do that. So don't worry about that.
We do want to stop and talk about the formula, though, because it does tell us a couple of things, right?
We don't need to actually do the formula, so just relax.
Right. So minus x bar over standard deviation of x. What's that, Mr. Bobby?
That's like a z-score.
That is a z-score. Y minus y bar over standard deviation of y. What's that?
Another z-score. So we're like z-scoring like crazy.
Now we got z-score of my x variables and z-score of my y variables, and then I'm going to multiply them all together. So
Z-squared?
it is important for us to look at the formulas and have some frame of reference just in case somebody asks us some really complicated questions about R values. We can go back to the formula and say, what would happen? Okay, we do want to remember that a perceived or real relationship between two variables does not mean that changes in one variable cause changes in the other. That is, correlation does not imply causation.
We talked about that. I remember you saying that before.
We did talk about that. So as whoa, I got a whole pointer.
What the heck? What is that?
I got a pointer.
Like, I didn't know how you did that. Oh, it's in the Google Slides thing. Okay.
I was like, I got a shooting star here. Okay.
Did you mean to do that?
No.
Folks, we both worked a full day, and this is the third video we recorded this day, so it's like going on 7 o'clock. We're gonna be a little punchy.
Okay, so kind of let's get our heads wrapped around just like what the R value means in terms of data. So the correlation R describes the direction and strength. This should remind you of Homer Simpson's favorite drink, Duff's. Of a linear relationship. That's right, I said linear relationship in a scatter plot.
So I'm trying to draw a line through this first one, and like I don't know how to do it. Like,
not a clue, right? Yeah, a lot of times people think, well, if I pick the first dot and the last dot, then I'll get a pretty good estimate. Well, I don't even know. I guess the first dot would be which one? The one furthest to the left.
And this one, that one I don't like. Ugh.
Okay. Yeah, so tough, right? So correlation to 0 means there's absolutely no linear correlation in the data.
Right.
So in the next couple of them, we say like correlation of -0.3. So why do we think it's negative?
Well, I mean, if you go back to remember when we were kind of looking at this before, I was circling them. So like I was trying to encapsulate them. And if I were to draw that around the first one, I would have drawn a full circle. But if I were going to draw something around this one, I need a really wide like oval, but an oval that's going down and to the right.
Right. And then the next one we're looking at is a correlation of 0.5. So this one's positive. So why do we think it's positive? Because the data looks like it's trending upward. Now, we went from a 0.3 here to a 0.5 here. So we're getting closer to 1. And if you notice, it's hard to see it in this one, but our data is beginning to come together and look more and more like a line. Correlation of negative 0.7, you've got that downward trend, and the data is kind of squishing together more and more like a line. Correlation of 0.9, we're squishing together even more, but this time trending positively or trending up. Correlation of negative 0.99, you got a really good cluster that looks like a line. Now, guys, it's important for us to note that in real life, a correlation of 0.99 does not happen. It is just like such a rare thing for, we're seeing the loud puppy. Is that who we're seeing? You know, you're
this is a skinny puppy, right?
yes.
So her R value would be closer to 1.
Oh my gosh.
And this is a fatter puppy.
I can't with you right now.
This is round one, by the way.
That's the blob. That's a correlation of 0.
When it's nice and fat and round like this, correlation is 0.
Okay, so here's what's going to happen now. Mr. Bobby and I are going to play Guess the Correlation. And so that means we are going to, thank you for clearing the screen. We are going to just do one round here of who can guess the correlation better. So I'm just going to type his name here. You in, Mr. Bobby?
I am.
Okay, we're going to hit start. We're going to hope that we get to play a game here. Not yet.
Do I need to type your name in too?
I don't think you played a second ago. Did you put it in last time?
I didn't, but I can this time. It's not letting me type it.
Well, we may be failing at this and just jumping back, and it was boring and yucky.
Oh, I got it now. I got one. Oh, wait, no, that was just was that a single player one? No, hold on. 2 players.
Is your name in there?
It is. It says username Corey.
Aw. Maybe I'll go play a 1 player if it won't let us play each other. By the way, we played this right before you guys, or right before we started this video to make sure it works. Obviously, that was a big fail, and I won.
We did.
So, actually, we can just do it this way. Mr. Bobby,
Wait, I got it. All right, try it again. Go back.
I got you. We're playing.
We're playing now.
So I'm going to talk you guys through it. I'm looking at this. It looks positive to me. It looks like it's increasing, but it's really scattered. So I'm going to go with 27. No, I'm going to go 32. 32. Wait, did you wait to plug yours in until you heard my guess? You're so rude. Mr. Bobby won. I guessed 0.32. He guessed 0.34. The true R value was 0.40. So that means he wins because he was closer to the 0.40. Although I feel like that's cheating a little bit.
Just a little bit.
You guys can see that I have way too many tabs open here. So that is the R value and how you kind of think about how much the number is and how that pertains to the graph. Okay. So let's say we have a scatter plot, and the scatter plot is talking about the relationship between payroll and millions of dollars and wins for the MLB teams in 2016. Okay, so if they this person had 60 wins or this team should have or has 60-ish wins and average payroll is just over 100 million, right? So that's kind of how this works. The R value is 0.613. So what is that R value telling us? Now, if we back up and think about like direction and strength, we want to make sure we comment on those things, right? So we might say something like the correlation R is equal to 0.613 is evidence. Mr. Bobby made me change this for you guys.
Yeah, I wanted her to be wishy-washy here.
Yeah.
It's not to prove anything, but it proves or provides evidence that, hey, we're like out here. I don't know if you can see my cursor, but I guess I can circle it.
Yeah.
These guys, this is probably them that are Yankees out there. Okay. And even though they paid a lot of money, they didn't win the most games, but there is a relationship. Like there's my Pirates down there. Okay. Anyway.
So we would say that this is evidence that there's a linear association between payroll and number of wins, and it's moderately strong and it's positive. So it's increasing.
And that's the direction. Doesn't seem to be any unusual points, although I did talk about a couple.
Yeah.
So and so on.
Yeah.
Okay.
All right, let's look at the next one. So here's another graph. This time we have a scatter plot that shows the 40-yard dash times in seconds and long jump distances in inches for a small class of 12 students. And the correlation is negative 0.838. So what does the negative tell us, Mr. Bobby?
That the line is going down, would be going downhill. The slope would be negative.
So as the dash time increases, the long jump time increases. What did I just say? As
the dash goes up, the jump goes down.
Yeah.
The less you can jump.
Yeah. And then the fact that it's 0.838 tells us what, Mr. Bobby?
That's pretty daggum strong.
Yeah, it's pretty strong. So the correlation R equals negative 0.838 is evidence that the linear association between dash time and long jump wins is fairly strong because 0.838 is fairly strong, and negative because it's negative. Make sure that you aren't just putting association and that you're putting the word linear in there. R values only pertain to linear association, so that's a really important part of your description.
And you must also have context. You can't just say negative association because then we don't know that you're even looking at the problem. You have a 50-50 shot.
Right, right. Okay, so we've looked at this graph before. This is our median income in Arkansas since 2000, and we kind of talked about it without a number associated with it. We did a whole workup on Duff's. So now we have a number, 0.38. 0.38 tells us what, Mr. Bobby?
It's pretty weak. It's not
pretty weak. It's positive.
It's positive, but it's not. Yeah. And I think we even watched a little video about stuff. So, but if I were to circle it, I'd have to have a pretty big blog, but bring Holly back at you. Okay.
Not the chunky dog. And then if we look at California, what do we notice?
Even worse.
Even worse. Almost zero. Like you can really like this just does not look like a line. Okay. Also important to remember again that correlation does not imply causation. So let's look at this graph. Just consider the following scatter plot showing the total revenue generated by skiing facilities in the United States. And then also by the number of people who died becoming tangled in their bed sheets in 10 years. The correlation for these data is 0.97, which tells me that the more people that go skiing, the more people that die in their bed sheets. Yeah. That's what it tells me.
That's not what it tells you. It just tells me that somebody put some data together, and there's a lot of stupid people who can't sleep successfully. There are 800 people, even 800 people that die from, and well, you say that's a span of 10 years, but still, right. That's like 80 people a year dying in their sheets.
by becoming tangled. Not even just like dying in bed, like they're dying because they became tangled in their bed sheets.
Well, we're the country that did make Snuggies because we don't know how to use blankets. So
Truth. Okay, so Mr. Robbie's actually going to steal the screen from me for just a second. And I want to really hammer home the fact that the R value pertains only to linear relationships. So I'm going to hand the mic over.
all right, so well, she's still here. She's just I'm presenting one, and that's fine. But if you look at this data, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. If you had to come up with an equation for that, it would be y equals x squared.
We
right?
know, anyways.
We should. Like if you've made it to senior high school, through senior high school, like these are square numbers of these numbers. So if I were to graph it, it would be, I'm going to turn that regression off for a second. It makes a parabola, right? I could draw a perfectly beautiful y equals x squared through it. Okay.
Right.
So what I want to do is, we know this equation is y equals x squared, but let's pretend I'm not, and only thing I can do is run a regression that is linear.
Now, we hope that you have seen this regression in a previous math class, and this is not coming out of nowhere. We're going to talk more about how to make this line later on in your course, but we can't talk about an R value without talking about a line. That's why we're throwing the line in there that best fits this data.
So this line is what the calculator thinks is the best line that fits this data. Y equals 2, because that's actually 0 times x. Okay? And when you run a regression on the calculator, it actually computes the R value for you. So I'm going to insert a page here so I can see the R value. It's actually computed under var, and I could choose R. Right now, when I choose it, it tells me that the R value is 0.
So if you're not careful, what you will say is there is no association between the X and the Y values. Well, of course there is an association between the X and the Y values. It's y equals x squared.
Yeah, I told it to you like half an hour ago, right? It's y equals x squared, but there's no linear relation between X and Y. Okay, and so what I've done, now let me change the game here a little bit and maybe change this so it looks like it's exponential. Y'all probably are familiar with y equals, how do I do this right? Because it's been a long day, all right?
So you're noticing that pretty exponential curve. Like remember, exponential 2 to the 0 is 1, 2 to the first is 2, 2 to the second is 4, 2 to the third is 8, and you get that pretty exponential curve.
So now if I try to find the R value and then get it in here, it's going to tell me 0.88. That's pretty strong. That's pretty big. That's close to 1 or pretty close to 1.
So if you're not careful now, you'll say a line is the best model for this data. So this is the flip side of that, of saying, okay, now I have an R value that's really good, and then assuming too much because of that R value. So you don't want to underassume and you don't want to overassume is kind of the point here. So if we had a line that was perfectly linear, and this might not be perfectly linear, but it's pretty close, right? Then our R value would be 1. So 0.9988, that's pretty close to 1, right? So we always want to ask ourselves, like,
now it's,
does our grandma affect this line, right? In the same way that, like, if I'm trying to figure out if somebody's bringing in somebody super different is going to affect the median or the mode, we want to ask the same question about the R value. Like, if I have an outlier, does it affect the R value? Well, you can obviously see that it affected the line itself. How does it affect the R value? So remember, this was 0.9988 before he brought that point up to create an outlier, and now it's negative 0.23.
So 1 outlier can really impact the regression line and the R value. Okay, so the R value tells you something, but it alone is not the end all be all. You need to look at the graph as well as the
Don't just assume because you're seeing an R value, you can actually say something about the graph. You need to see the graph. You need to plot the points. Look at them. You need that visual. The R is not enough. Okay, so let me remember where my screen is. There we go. Did I share that?
Nope.
Of course not. That would make too much sense. I don't even know where that's participants. I said this was going to be seamless. He did not want to do this because he was like, no, let's not do that. Oh, it'll be seamless, Mr. Bobby.
Oh, well. At least
Okay.
I didn't get wrong anywhere.
That's true. That's true. So just really important here to say that the correlation is used to describe only linear relationships, the R value, only linear relationships. It does not tell you that it has to be linear, or that linear is the best form. It only tells you that if you're looking at it and it appears linear, it can help you with your argument. And then also that it's not resistant to outliers. If I have an outlier in the data, it's going to greatly affect my R value. Okay, so let's look at this. It says most people love chocolate for its great taste, but does it also make you smarter? A scatter plot like this one recently appeared in the New England Journal of Medicine. The explanatory variable is the chocolate consumption per person for a sample of countries. The response variable is the number of Nobel Prizes per 10 million residents of that country. And the first thing we want to discuss is, if the people in the United States started eating more chocolate, could we expect more Nobel Prizes to be awarded to the residents of the United States? So, Mr. Robbie, what do you think? Does chocolate make us smarter?
I would kind of really like that to happen.
I would eat all the chocolate. Wait, I already eat all the chocolate.
This is the kind of thing you hear on the news sometimes, or hear stories about that such and such does such and such. You wanna maybe think about it and try to figure out if there really is a relationship. There isn't. There's probably no.
Yeah. So no, of course, we cannot assume just because we've got this graph and an R value that's 0.791, we cannot assume that it causes that, because correlation does not mean causation. So looking at this graph here, Mr. Bobby, what do you think about Switzerland? So what do you think R value is telling us about Switzerland? So Switzerland is this point up here. It is different than the majority of the points, so we would consider it an outlier.
They've gotten a lot of Nobel Prizes, but they also have, they eat a lot, but that has something to do with culture too. I mean, I've always heard of Swiss chocolate, right? And everybody likes Switzerland. They're like the friend that everybody wants to sit with at lunch.
That's like the popular kid.
Yeah. So, from what I understand, the Nobel Prize is kind of a popularity contest, right?
No.
No.
Nope. Don't go there.
All right.
Okay, so in this case, Switzerland, even though it is an outlier, it appears to be different, where, he was saying like, wow, that's a lot of chocolate consumption, and also, wow, that's a lot of smart people. It's still in the pattern of points. So in the pattern of points means it's going to strengthen R. And if it strengthens R, that means it's bringing it closer to 1. Okay, so then what does that mean about Sweden? Sweden is also an outlier. Is it within the pattern of points?
Doesn't seem to be.
Doesn't seem to be.
But that's where Nobel Prizes originate, right? Or don't they come out of Sweden? Or is that the country that it's based in?
I don't know, actually, where they're based.
Yeah.
So what happens is, because this is not in the pattern of points, the Sweden is outside that pattern, it's actually going to weaken our R value because it's not in the line. And so it's going to bring our R value closer to 0. Okay, let's do one more. Is this the last one?
I think so.
I also think so. So it says the following scatter plot shows the height in inches and number of steps needed for a random sample of 36 students to walk the length of the school hallway. This one's very interesting. the correlation is negative 0.632. So my question for you, Mr. Bobby, is why is it not correct to say that the correlation is negative 0.632 steps per inch? Steps per inch.
It was like steps per inch makes me feel like it has a rate or something, and that's not what R value measures. It just measures how strong the relationship is or how weak the relationship. It has nothing to do with the actual people walking down the hall.
Right,
It
right.
doesn't have any units on it. It's just R is like, a rating.
Yes, it is.
Means
it has violence or no. So remember, as I told you, sometimes it will be helpful for you if you aren't sure how to answer the question to go back and look at the formula. So remember, this is z-score times z-score, and a z-score is a standardized score where we just take the units off. And so in this case, we would want to answer saying something along the lines of correlation is calculated using standardized values, I'm hiccuping, and does not have units. Just hiccup in the middle of my explanation. It's awesome.
Yeah, that's all right. This lesson's been interesting to say the least.
B says, what would happen to the correlation if number of steps was used as the explanatory variable and height was used as a response? So what would happen if we switched what's on the X and the Y?
You'd still kind of have the same kind of relationship. You just have the values interchanged.
Right. Remember, come back to your formula if you're like, I have no idea. And what would happen in your formula? Well, your X would become your Y and your Y would become your X. And so they would swap positions in the formula right here. And so can we do that? Can we just swap like this? Absolutely. 2 times 3 and 3 times 2, same number. So actually nothing interesting would happen when I swap explanatory and response, and I, get the same R value.
And another way of thinking about it, it's still the same relationship. We're just turning around the variables. There's still if there is any kind of correlation there, it would be just as strong if I look at it from one direction or from the other.
Right. C says, what would happen to the correlation if height was measured in centimeters instead of inches? So if this becomes centimeters, my numbers change, right? 60 inches and 60 centimeters aren't the same. So I would have to convert all these numbers.
The z-score, you're using z-scores. So
yeah. Keep coming back to that thought that R values use z-scores, and those are standardized scores, and they don't have anything to do with units. Okay, so that's it. You're going to do 2 things. The first thing you're going to do is go to Khan Academy. This is going to take you like no time at all, like maybe 5 minutes to do the first thing. And then the second thing you're going to do for the very first time is go to your textbook, go to page 158 through 162, work numbers 4, 10, 22, and 26. You do not have to write the flamingos. You do not have to write the questions if you do not want to. Just answer it, make it legible, and then scan or take a picture and submit. So thanks for joining us. We will see you on the flip side, or maybe just on the next video. Bye.